All right, let's dive right in. We're talking about taking your AI assistant, you know, the one that's super powerful but sometimes just goes off the rails, and turning it into a reliable, programmable partner. We're going to get into something called Claude Code Hooks, and trust me, it's a game changer.
So, you've probably been using an AI copilot, right? They're incredible. But we've all had that moment, that split second of hesitation, where you look at the code it just generated and think, wait, can I actually trust this? I mean, they hallucinate, they make mistakes, sometimes they suggest something that's just plain dangerous. So yeah, the big question is, can you really, truly trust them with your code?
And that's the real tug-of-war, isn't it? You've got this incredible promise of speed and power, like you're coding at light speed. But then there's the problem. It's unpredictable. It could be unsafe. You get this massive productivity boost, for sure, but you're giving up a chunk of control. And for an engineer, that's a tough pill to swallow.
But what if you didn't have to make that trade-off? What if you could flip the script entirely? Instead of just typing a prompt and crossing your fingers, what if you could put up your own guardrails? You know, build your own safety nets and basically program your AI partner to follow your rules. Well, that's exactly where code hooks come in. Seriously, the best way to think about them is like middleware, but for your AI. You know how middleware in a web app sits in the middle, intercepting requests and responses? Code hooks do the same thing. They sit right inside the AI's workflow, letting you jump in and take control at the most critical moments.
Okay, so let's get a little more specific. What is a Claude Code Hook? Well, it's basically a checkpoint, a little stop sign in the AI's process where you, the developer, can inject your very own code. It's your chance to look over its shoulder and say, hey, what are you doing? You can approve it, you can block it entirely, or you can even whisper some extra context in its ear to help it do a better job. You're in the driver's seat. And we're not just talking about 1 or 2 places you can do this. Nope. There are 13 of them, 13 different moments in the AI's lifecycle that you can hook into. That is a ton of fine-grained control, from the very instant you hit enter on a prompt all the way to the final response it gives you.
So let's walk through a quick example of this in action. It all starts when you submit a prompt, right? Boom, the UserPromptSubmit hook fires. You can jump in right there. Then, let's say Claude thinks, okay, I need to use a tool for this, maybe write to a file. Well, before it even tries to write that file, the PreToolUse hook fires. That's your chance to step in and say, hold on, let me see that. And after the tool runs, another hook, PostToolUse, fires. See, every one of these steps is a chance for you to intervene and steer the ship.
Okay, so that's the what. Now let's get to the fun part, the how. In this next section, we're going to look at how you actually use these hooks to get that deterministic control we've been talking about. This is where we turn our AI from a kind of wild, creative partner into a tool that we can actually, program.
All right, let's start with the most important one, security. Just imagine this. You give your AI a kind of vague prompt, something like, clean up the project directory. And the AI, in its infinite probabilistic wisdom, decides the best way to do that is to run, well, this command. Yep, rm-rf/, the command that sends a shiver down every developer's spine, deleting everything from the root. And look, without any guardrails, a smart but literal AI trying to interpret a fuzzy command, it could come up with this. It's the classic low probability but catastrophically high impact risk.
But here's where our hook saves the day. Just look at this. The AI tries to run the command, but that PreToolUse hook we talked about, it jumps in and intercepts it before a single byte is touched. Your code can scan that command, see the rm-rf, and go, absolutely not. Then it just returns a special exit code that tells Claude, stop, do not pass go, block this operation. And just like that, disaster averted. It's a rock-solid programmatic security gate.
And hey, it's not just about playing defense and stopping bad stuff from happening. You can do so much cool, proactive stuff with hooks. You can log every single prompt for your audit trails. You can automatically inject context, maybe inject your team's coding style guide into every prompt so the AI always follows your rules. You can use a hook to double-check that a tool's output is valid. The possibilities are huge.
Okay, so let's kick it up a notch. We've gone from just prompting to actually controlling an AI. The next step? We go from controlling one AI to orchestrating a whole team of them. This is where things get really futuristic. We're talking about the dawn of a whole new field here, something people are starting to call Agentic Engineering. And the core building block for this is something called a sub-agent. Here's the idea. Your main AI agent can act like a project manager and delegate specific jobs to these other specialized AIs. Each sub-agent is its own little expert.
It has its own unique instructions, its own set of tools it's allowed to use, and its own memory. So you can have one agent that's a genius at code reviews, and another that's a master of running integration tests. Each one stays in its lane and does its one job perfectly. This all leads to a really powerful mindset shift. It's not just about getting the AI to do a task for you. It's about thinking bigger. It's about figuring out how to scale it up. It's about building the thing that builds the thing.
And that's where you get to this incredible concept, the meta agent. It's literally an AI that builds other AIs. It's a sub-agent whose one and only job is to spin up other sub-agents. So you can just tell it, hey, I need an expert on API documentation. And poof, the meta agent creates a brand new specialized agent just for that, with the right instructions and tools ready to get to work.
Okay, so now you've got this factory churning out specialized AI workers. Awesome, but how do you make sure the work they're doing is actually any good? How do you do quality control? Well, you do it the same way we humans do. You create a team and implement reviews.
And this leads to a super clever setup called the builder/validator pattern. It's simple, really. You have two agents. The first one is the builder. It's the doer. It has all the tools, it writes the code, it gets the job done. Then you have the validator. This one is the inspector. It has read-only access, so it can't change anything. Its only job is to check the builder's work and make sure it meets the requirements. It's an automated system of checks and balances, which is how you start to build real trust into this whole process.
So when you put all this together, you realize this is way more than just a new feature. It's a fundamental shift in how we think about building software. We're leaving behind the era of just chatting with an AI assistant. We're now entering the age of agentic engineering. We're becoming designers and managers of entire systems of autonomous agents that can tackle really complex problems.
So let's just quickly recap the big ideas here. First, code hooks let us go from I hope this works to I know this works. We're moving from probabilistic to deterministic. Second, sub-agents let us scale by delegating. Don't build a monolith, build a team of experts. Third, patterns like builder/validator automate quality control so you can trust the output. And the most important takeaway of all, we're not just prompt engineers anymore. We're becoming systems engineers, building robust systems with AI as a core component. Which leaves us with one last kind of mind-blowing question to think about. When you can literally deploy automated teams of AI engineers, teams that can build, test, and even review their own work, what does your job become? I mean, really think about that. Does the role of a human engineer shift from writing lines of code to being more like an architect, a designer of AI teams, an orchestrator of these incredibly complex automated workflows? It's a huge question, and it's one this technology is forcing all of us to start thinking about right now.